Okay, welcome back, everyone. We are on Wednesday, May 5th, week 1, day 3, programming basics. We're going to go over parameters, functions, and operators. And I want to mention, just want to reiterate, if you are ever late or want to make up that time, you can go to the TA office hours. The time spent there will make up for that late that you would have accumulated on your record. You do have to make 80% attendance. So if you miss one full day for programming basics, that's already 80%. And so just want to let you know, and you have an overall attendance you want to keep clean. So if you are late and you want to make up that, and you want to erase that, if you don't have a valid excuse, you can go to the TA office hours and that time is counted to erase that time that you were late or make up for it. Okay. Any other things I should mention? We want to, if, I want to enforce the 20-minute rule, ask a cohort mate if you get stuck, but don't feel like you shouldn't drop in my room to ask me a question. You do get college credit for this course, but it's not like a college instructor type of environment where you can't approach because you may be bothering time. Just come in my room, ask me what you need. If, don't get frustrated and stuck on a problem too long. Come into my office as well as the TAs. Even if it's right after a lecture. Oh, there's one more thing I wanted to mention here. I'll remember it. I'll mention it at the end. I'll just make a note if I remember it. Okay. So we want to go over these topics: parameters, functions, and operators. Okay. Let's go over operators first. I know it's last on the list here. I should have moved it to the front, but it doesn't matter. Operators is what we're going to tackle first. We were going to do that this morning, and then we moved it to this afternoon. So let's do that now. And then we'll go on to functions and parameters. Okay, so we're going to do a bit of simple division. I'm referencing the platform here, operators, modulo, and this is where you would have to reference the platform if you are wanting to remind yourself how this works. Okay, so let's go over how to make this work. Okay, let's do some division. Modulo operator. Okay, so what's 5 divided by 2? Someone say it or just type it.
2.5.
Okay, but not as a decimal. What's the answer not as a decimal?
2.5.
2 remainder 1.
Okay, there we go. That's what I'm looking for. 2 goes into 5 twice, and the remaining after it divides into 5 twice is 1, right? 2 remainder 1. Okay. So what the modulo operator is asking, or the way it works, is it takes into account the remainder after you do division. Okay, so let's restart the board here. Okay, so if I say 5, and this is the modulo operator, it's like the percent sign, 5 modulo 2. If I say, is this equal to 1? This statement is true because 2 divides into 5 twice with a remainder of 1. So this statement is true. Okay, that's how the modulo operator works. Let's write another statement. 5 modulo 2 what about this statement? What's the result of this statement? False, right? This is asking a question. This double equal sign is saying, is that equivalent, what's on the right to the left? And the answer is false. Why is the answer false?
Not equal to 0.
1.
Right. I know it's redundant, but let's say it so that way we don't forget it. All right. It's just a memory thing, because the remainder is 1, right? The remainder should be 1. So therefore this is false. Okay. This is how the modulo operator works. So therefore, when we use the modulo operator, one of its uses can be to find if the number that we're checking at that moment is odd or even. And I'll show you what I mean. You can have a number x, and x may change. If you ask if x modulo 2 is equal to 0, what are you asking essentially?
The number that divides into it equally with no remainder.
Yeah. Yeah, you're asking, is x an even number? Is x an even number? Right? So how would I find then if x is an odd number? How would I write?
Not equals.
Okay, there we go. That's one solution. So we can say if x modulo 2 is not equal to 0, then we know, then that's how we can ask, is x an odd number, right?
And just a quick question, the modular is that's the percentage key?
Right.
Okay.
Can you also say x or like equals 1?
Exactly. That's another way. Okay, so we can do that way as well. We can say x modulo, how would you write it? X modulo what?
I don't know.
Okay, you can ask if x modulo 2 is
equal to 1.
yeah, what are we asking here?
Odd. Is it
Right.
odd?
Exactly. That's what we're asking. Is it odd? So there's multiple ways to get the same thing, different versions of it. But this is how the modulo symbol works. It divides and then calculates a remainder, and you ask if that the way you can use it is by asking if that remainder is this or that, odd, even, 0, 1, or you can ask if something is you can find if something is a multiple of 3. right? How would you find that? If you say x modulo 3, you're asking, if you say equal to 0, you're asking if something can be divided by 3 evenly and not have any remainders after, then, that's how you find the modulo of that. That's how you calculate it. So you can use any number you'd like, basically. Does that answer that question, John? Okay, good. All right, so let's go ahead and move along. There's other operators that we can work with. Let's go over what these are. Okay, these are inbuilt JavaScript methods. Remember that we had this math library that we said that the writers of the JavaScript had built a library of mathematical methods, things that you can do related to math. And now what we're going to do now with this math library is math.round. Okay, so do we know how to round numbers? When we write a list of numbers 1 through 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then if we want to round, we take 5 and up. Okay, 4 and below. Oh, I drew the arrow the wrong way. 4 and below round to 0. Okay, when we're thinking of decimals or just rounding a number. Okay, to the nearest 10th. So what this is doing here is saying var num1 equals math.round 2.5. Okay, you call the math library, you say what part of the math library you want to call. So that's how you say .round. You're accessing that part of the math library. And then you say 2.5. You put the number that you want to round. And because it's at 5, it'll round up to 3. Okay. Oh, you know what? I forgot to do something. Let's take a poll for the modulo, and then also we'll take another poll for this new topic. But need to ask you guys, how do we feel about using modulo symbol? Okay. And we'll use more modulo symbols, especially next week during the morning algorithms. Think of its uses. Let's say you're given an array of numbers, and you want to check for each item that you read if its value, right? Each index, if its value is even or odd, you can use the modulo. You can use that modulo statement within an if statement to do that check. So let's do a relaunch of the poll. Let's ask about using math.round, that library, to find out to round a number, a decimal. Okay. So let me just give a quick example of how this could be put into use. Let's do the first one. Var num1 equals math.round at 2.5. So what we want to do here is we'll go to our trace code runner and we'll paste it here. So it's attached to num1. Var num1 was created to have this value of math.round 2.5. So what we need to do is console log something so that we see a print of num1. Okay, so we'll say console.log num1. Let's see the value of that. It should be 3, right? So we should see in our terminal when we run the code the number 3, and that's what we're checking. I'm just giving an example of how math.round can be used. Okay. So here we got 3 at the very bottom. I know it's a small little green 3, but it's there. And we have num1 to equal 3 in our T diagram here. Okay, so this is how you could use math round. You assign it to a value, and maybe you can use that value somewhere along the lines in your code. You can console log it to see what it is, and it'll show you it's 3. Okay, so there we have math round. We have math.floor. What math.floor does is it always rounds the number down, no matter if it's above 5 or not. Okay, so let's see what math.floor is in our trace here. So we're going to console log num1. Nothing's changed. The variable name is the same, except for now we're using .floor. And actually, I'm going to change this. I'm going to make it to be 2.9. So let's see what happens. Let's predict what it's going to be. If you want to type it in the chat before it loads.
2.
Okay, that's what math.floor does. It takes the decimal of any number and it rounds it down. And so what that means for negative numbers is let's see what well, it says it here. Negative 2.9 is going to round down to negative 3. Right? That's going down because it's in the negative area. It's a negative number. Okay. A negative 2.1, if you math.floor it, going down, it's going to go down to negative 3. Okay. And that brings us to our next JavaScript library math operation here, math.seal. That rounds the number up. So let's see how negative 2.1 is treated in math.seal. Negative 2.1 goes to negative 2, okay, because it's going upward. And everything else goes up. 2.5 goes to 3. 2.4 also goes to 3. 2.1 would go to 3. Again, negative 2.9. The ceiling would be to go to negative 2. You're going less in debt, right? Going up would be to go to negative 2. All right, so let's take a quick poll how well we're understanding seal and floor, math.seal and math.floor. Okay, if you ever need to see me put this into action, like put it into trace or the JavaScript debugger, you know, don't be shy to ask, either in chat or in, you know, to speak up. Let's see what math.trunk does, okay? Math.trunk I didn't well, here's the value on the T diagram. Math.trunk takes the n, the decimal, and just takes it off completely. So it doesn't matter what it is. It could be, you know, 1 through 9. It's going to just chop it off completely, and it's going to leave the integer without it being a decimal. It's going to be a whole number. Okay, so 2.5 is 2, 2.4 is 2, negative 2.9 is negative 2, negative 2.1 is negative 2. Okay, these are all inbuilt JavaScript functions that we need to have in our back pocket, know how they work, know what they do, because we're going to be putting them into application in next week. Right? They sound kind of cool. Math.trunk, math.seal. Imagine if your name was Math Seal. It would be so weird that people would probably respect you more. It's like Elon Musk. Elon Musk, when I hear it, it's a weird name, right? It sounds different. Like, is that why people pay attention to him? I don't know. Doesn't matter. Going off topic. Anyways, let's go on to the next topic. We have functions and parameters, and we can handle them both at once. All right, so we'll do both functions and parameters. Actually, we'll do functions first. Okay, let's do functions. Okay. Oh, before we do that, I think I already did a pulse check on math.trunk, didn't I? Just want to make sure. Let's just do it just in case I didn't. Math.trunk, let's do a quick poll before I switch over and I draw on the screen here to explain functions. Okay, good. That's good feedback. I like that. We're understanding. Okay, let's go ahead and explain functions. Okay, and we're making good time, so yeah, let's get started with this. All right, who can tell me just in your own words what a function is, either in the English language, in JavaScript, and however you understand that word function? What does it do? What is it?
It's a container, right?
Okay, all right, so a container. I like that description. Who can tell me another description? Structured formula, okay. Formula. Okay, code to be executed. I like that.
Set of instructions.
Set of instructions. I think it's getting more wavy as we go. It's like a program, a mini program, right? Program can maybe just have one function if it's that simple of a program. Okay, so a function is all of these things. It's a definition of what to do. Okay, here's what to do. Okay, we're going to, I tend to use the analogy of like a microwave when I'm describing a function, and it's not the best analogy always because it's kind of hard to retain. All right, so that's that. In that sense, it's like a container. It's like a machine that takes something in, and then you press the buttons, and then you press the start button, and it does something. All right, you give it a set of instructions, and that function does something. Okay, when we're solving a problem, an algorithm problem, we're building functions that would solve for that problem. Okay, functions can take different inputs, and we'll talk about that. That's called the parameters, the things that it can take in. Okay, but first we're going to just write a function that doesn't have any parameters. It doesn't take anything, and we're going to show how to write that in JavaScript. Okay, so let's go to that section, and I'll show you where I'm referencing this in the platform. I'm here in Introduction to Programming under functions and parameters. In fact, I'll go here to functions first. Okay, this what we're looking at here, this is a function. At the very base, this is like a shell. It has no code inside. This is like a hermit crab shell without a hermit crab inside. Okay. This is what it looks like. It's like an empty microwave with the door open. All right, so let's draw it out. We start with the keyword function, okay? So we type that word, function, and then we write the name of the function, okay? So let's think of a function name. I'll just call this one example. Okay, that's the name. And we also have to open and close these parentheses after the name of the function. This is where stuff would go in. Okay, this is where the function would take in information. But like I said, we're going to build it without that for now and just build an empty hermit crab shell without a hermit crab. So here's the do something section, as I've been calling it, of the function. Okay, here is where we tell it to, here's the instructions. Okay, that's where you write your code. When the function is executed, this is whatever you write in here is what gets executed. Okay, it could be a console log, it could be a for loop, it could be an if statement. Whatever it is, it goes inside these curly brackets. And usually, I mean, it's not required, but we like to indent on the curly brackets so they're on separate lines. Okay, and all the code would go on the inside. All right, so at the very base, this is how you write a function. You write the keyword function, you give it a name, open and close these parentheses, and then open and close these curly brackets, open it up and indent, and this is where you would write your code. Okay, let's get some feedback on how well we understand how to write a function. And as you can see, this is a container, right? Like this, the reason why we have these functions is so that we can execute different parts of our code at different times. What if you have a whole giant page? Let's give an example here. I'm going to delete this screen. I'm going to delete this screen. And here we have some JavaScript. We're going to expand this. And here we have two for loops, right? We have one for loop here. This is our first for loop. And this is our second for loop. What if I ran this page, if I made this whole entire page run, example.js, how would I make it that I could execute one for loop without executing the other? Because right now, if I ran this entire page, both would execute at the same time. All right. You can write, well, okay, you have an else. That's a creative idea to make a switch to go between this for loop and that for loop, right? Then you're wrapping it in an if statement that would take some parameters. But what we want to do, the answer that I'm looking for, is that we wrap each for loop. If we wrap each for loop in its own function, then we can call that function to be executed, and it would execute it would be executed individually from this for loop. Okay, these are sets of instructions. Okay. And if we want to divide the instructions, we need to wrap them into functions so that we can call the specific parts of these instructions whenever we want them to do something. Okay. So let's give an example. I'm going to take this function here. I'll paste it here. Now I'm going to take this for loop. And if I highlight it, hold the Option key and press the up arrow, I can move it like that. I'm on a Mac. I think it's Control on PC. And so here I am. Now this for loop is wrapped inside this function called name of function. I'm going to call it our example. Actually, second for loop. Okay, that's the name of this function. It's called second for loop. And I can also wrap this one here in its own function and call it first for loop. Now, if I put the closing bracket here, now I have two functions. Okay, by the way, you can right click the page and click Format Document, and it will organize the code nicely for you like that. Okay, so now when this page runs, it's not going to execute any of these for loops. It's only going to execute if this function is called. Okay, if this function is called. Okay, what does that mean? That it means that this function by itself will not allow anyone to run the for loop unless you call this function by its name. Okay, we're going to call this function by its name. The way to do that is by writing the function name and then opening and closing these parentheses. So I'll do that now. I'm going to call this function by its name. First for loop. Open and close the parentheses. This is the invocation of the function. Okay, these are the instructions. This is the start button for the instructions. Okay, this will not run. Line 5 to 9 is not going to run unless this is somewhere on your code executed. Okay, this is executed right after it's defined. As soon as it finishes reading line 9, it's going to get to line 14 and then realize it has to do everything from line 5 to 9. Okay, when this code is read, okay, ignore the function below. When this code is read, what it will do is it will read line 5 through 6. It'll acknowledge the rules. It'll understand, okay, this is what this set of instructions does. Okay, I understand this is what this is for, but I'm not going to actually do this. I'm just going to read it, understand it, acknowledge it. As soon as it reads line 14, then it's going to know, oh, okay, I actually need to do this now. I need to start this process. So I will go in and run this for loop now. But it won't do it unless it sees somewhere this here. Okay, this can be attached to a variable. You can say var start equals, and this variable now equals the invocation call. Maybe you can do different things with this. You can console.log start. Okay, there's another way you can do it. You can console.log the function invocation itself. You can say first for loop This is how you would see the function in the console, right? This is printing it directly to the console so that you can see what the function does, okay? Right now, it will just run a for loop. It won't print anything to the console when the function is ran. All right, so let's get some feedback on how well we're understanding this concept of wrapping for loops and if statements, different JavaScript text within functions so that we can run those bits of code only when we call that function's name. Okay, how well do we understand, or do we think we understand this concept right now? Okay.
Wait, so if we assign the function to a variable, would we still be considered calling it?
It would just be assigned to that variable. You wouldn't do anything with it unless you do something with this variable. You have
okay.
to
So
interact with the variable. Yeah,
we have to activate the variable if we want to call the function then.
right. Okay. Let me take a look at the schedule here to make sure I won't cover any topics for tomorrow. Okay, yep, let's move along here. All right, so that's a leading question to the next thing I'm going to introduce, which is the return, okay? And what the return does is give a value to the function, okay? So if we say return 5, first for loop is equal then to 5. And if first for loop is equal to what we tell it to return, which is 5, then start must also be 5, because start is equal to first for loop, and we said first for loop was equal to what its return value was, and the return value was 5. So this 5 gets woven in all the way to give this variable start the value of 5. So if I were to console log this, I would get a 5 to print to the console. Does that make sense?
I had a quick question.
Yes.
And this kind of goes back to, I think, Ryan's question. So now on line 16, right, when we declare an initialized start to the first for loop, like that first for loop function would be invoked, right? And we can see that when we return 5, right?
You said on line 15?
Line 16.
16, okay. Yes, so it is invoked, right? And it's given, and it's passing the value to that variable.
Right.
Right. Oh, did I say it wasn't invoked?
Ryan, that was your question, right? If it gets invoked right there? I just want to confirm that.
Yeah.
Okay.
Yes. So this is an invocation, and it's passing the value to that variable start. So when we console log start, we're console logging 5.
Wait,
Okay.
so for this specific code, if we assign a variable to the function, we're going to print out the number, right? Because it says console log num.
Console log num. Yes, it's also going to console log num. Every time this function runs, it's going to go through this for loop and do what it says. So it will console log num, and then
but then when we console log start the variable, we don't have, the console log doesn't work then, right? It just returns the value of 5.
it will go through this for loop. The console will print num for each increase, and then it will also console log 5 at the end.
Okay.
Yeah. So this is not ignored. This still prints to the console. It's just now, since we're asking for the value of start, which is the value of the function, which is the value of the return, it's still going to print 5 because we're asking it to be printed.
What's the definition of return again?
Okay, yep, the return, let's go over this on the blackboard. Okay. Return and what it does. First thing it does is as soon as you hit it, it stops and exits the function. Stops and your code exits the function. Okay, it's as soon as you hit a return, it's like Monopoly, you know, go straight to jail, do not pass go. You've ended the function. You're done. All right. The second thing it does is it gives its value to the function. It gives its value to the function. So let's write a small function on the left-hand side here. Okay. Function I. And this is what hi does. The only thing hi does is it returns the word hi. That's all this function does. It just returns the word hi. Okay. So when you have a return, as soon as you enter this function, it exits. Okay. And as soon as it exits, it gives this value, the thing that precedes it, it gives it to this function, its name. This is the name of the function, right? So whenever you see this value somewhere else in the code, you're actually, the value of this is what its return is, this string that says hi. So if you console log I, what would you expect to see? Yeah, easy enough, right? Does that make sense? The return just gives the value to the function. So when you console log that function, you're given the value that the return gives it. Does that make more sense now? Did it clarify anything?
Yeah, thank you.
Okay. All right, don't be shy to ask again if it becomes foggy. All right, so let's go on to the next topic, parameters. Let's get a poll feedback to understand how well we think we're understanding the return now. How the return gives a value to its function. It stops, it exits the function wherever you get to that return, and whatever precedes it, now you're giving that value to the function. Okay, we're creating lots of dots and connecting the dots here. So I know it's a lot of information, but when you know what, well, I've seen a lot of students make it to level 12 of the algo app and return doesn't click until they get to that level. It's like they've been working with it the whole time, but it doesn't fully sink in. And you know, I'll work with you if that's what it takes. We'll understand together how the return works if you want to work on the algo app together. But it's about that level that it'll finally sink in. I've worked with return as a developer, not knowing its how, with clarity what it does. But that's what it does. It passes on whatever is preceding it or proceeding it to the function. So whenever you call the function, you're getting that value from the return. Okay. All right. So we've covered functions. The last thing that we need to do is cover parameters. Okay, that's the last thing that we see on our list for today's lecture. And we have about 10 minutes left, so we have perfect timing to do that. Let's cover parameters. And if you want to access this in this content in the platform, it will be here. You would go to functions and parameters, and then you go down to this section here. This is where I'm getting the information from. Okay, excuse me for like 10 seconds while I close the window here. Someone's mowing their lawn. It's driving me crazy. All right, so this is what we're going to be looking at. This is a function that that takes in information now. This is where the section is that we said if we take information. So give me a second here. It's like people in Texas religiously mow their lawns here. So I like that, but it's like, man, you always hear that lawnmower. Okay, so let's now write a function that takes in some parameters. Okay, so let's do that now. Function with parameters. We've already been working with parameters. You've already been doing it. Maybe just haven't noticed. Okay. So let me give you an example. An if statement. Okay. An if statement. When you write an if statement, the stuff that the if statement receives in order to get to the do something section, stuff where you do something, you tell it what you want it to check in here, right? In this parentheses area. Okay, so that's a function is somewhat similar in that it has its own parentheses area, and that's where it receives its parameters. Okay, so let's write a function. Function. I'm going to call this function panda. That's just the first word that came to mind. It doesn't matter what you call it, okay? It has to be relevant to what you're doing, but I mean, in this case, it's not going to be.
Apparently it's National Koala Day if you wanted to do that.
Oh, well, too late. I missed. I chose panda. Okay, so what panda does is it takes in a parameter x. Okay, this is a placeholder for some value that it would receive. Okay, panda's going to receive a value. We don't know what that value is. We're going to just put x because we don't know. Okay, this function can be called with any number, but right now it's going to be x. And what it does with x, it says x plus equals 3. So we're going to add, and my 3s are like abominations. All right, 3. Sorry, made it worse. So we add 3 to x, and then we're going to return x at the end. Okay, so this just receives x, adds 3 to it, and then returns it at the end. This is where are these are the parameters. These are the parameters. Okay, this is the placeholder to receive X so that it can do something with X in the function. Okay, so how do we pass a value onto X? Can anyone give me a guess?
By creating a variable on the outside,
Okay, and what would that variable do?
it could be passed into that.
Okay, yeah, all right. I think I understand what you're saying, but let me correct some of the verbiage here. So what we want to do is invoke this function. All right, that's the start button. That's how we make it go. So how do we do that? We have to call this function. So we're going to call it. Let's make it in green. So it's like go. Okay, green for go. So we're going to make panda start. We're going to give a value now so that it can give a value to X. Remember, this is the start, right? You call it by its name, you write the parentheses. This is the start button to the function. So we're going to give it the value of 3. So now, if we give it the value of, if we call this function with 3, 3 gets passed into here. Okay, X, it's given to X. X is here. So we say 3 plus equals 3. So when we return X, what are we returning?
6.
Exactly. So if I were to console log this, what would appear on our console, our terminal?
Would it be 6?
Yep, it would be 6. Because when we call panda with 3, we're passing 3 to X, then we're returning that value X, that new value X with the value of 6. We're giving it to that, which passes along to here. And so this invocation call with this number, when we console log this, we are getting the return value. Correct.
Can you explain how you get 6 again?
Yes, we'll do this again. Okay. Let's do this with this example now.
And we do it in code, like VS Code or
yeah,
Trace.
we're gonna work in Tutor. Not Tutor, but Trace. So let's copy this code. Oops, wrong one. Let's erase everything in here. And let's start without any function call, any invocations, okay? Let's just see what happens when we have a function defined by itself, okay? We don't have any start buttons. We don't have any any parameters. Let's see what happens when we just run a function like this by itself. Let's run it. Okay. Here we are. What happened? Who can tell me what happened?
You did not call the function.
Right? And so nothing happened, right? Like there's nothing on my T diagram. There's nothing in my terminal. That means that when it read this code, it just acknowledged, okay, you have a function. You have a list of instructions. So what? I'm not going to execute it until you tell me to execute it. So nothing is going to console. There's no hello partner, greetings earthling, nothing like that. It's going to happen because the function was not called. It was not invoked. There's no start button pressed to make these list of instructions go. Okay, so now let's add back let's add a function call back. Okay, let's make it a simple function call. No parameters, nothing. Okay, and at the end of this if else statement, I'm just going to make a console log happen. Console log hello. I'm going to console log hello, and that's on the same level of this if else statement, so it's going to run no matter what. All right, so now that we have a function call, right? It's the name of the function with the parentheses. Let's see what happens. I'm going to run the code. Okay, and what happens? There's an error. Person is not defined.
There was nothing inserted into the area to call.
Right.
function?
Well, see, what happened was because we erased the parameter, and this if statement assumes that there is a parameter that would be entered, it's checking person if it's Martin. And because there is no parameter here called person and no value that we pass to the parameter, this if statement is crashing the running of the code, because it's basically freaking out saying, what is person? What do you mean by person? I'm supposed to check if person equals Martin, but I don't know what you mean by person. What's a person? Okay, so let's even simplify this even more. Okay, let's remove the if else statement. We just have a console log in this function call called greet someone, and we have it called now. So all we should expect now is the console to say hello. Okay, and what do we get? We get exactly that, right? Terminal says hello. That's all this function was supposed to do. So when we started it, that's what it did. It's finished. Now let's add back a bit of the code that we deleted. Okay. Now we have this if else statement, and we know it's not going to run unless this person here has a value. So we have to write it here so that it can receive it from here. Okay, wherever you have something in the function defined that's not in the parameters, it's not going to know what it is unless it's defined in the parameters. Okay, and what do we predict is going to happen if I press the run now? What's going to happen if I click run?
Hello, Martin.
Hello, Martin. Any other guesses in the chat?
Martin.
What happened here? Yep, we got
Greetings.
greetings Earthling. Right? Because what happened here? Was person equal to Martin?
No.
Okay.
And why not? Why wasn't person equal to Martin?
Martin, yeah.
Okay, so how would we make this then print this hello partner?
Pass it the value of Martin.
Exactly. We have to give it Martin here. This is how we pass let's see my Zoom drawing tools here. Okay, got it. All right, so this is how we pass Martin to person. And this is how this person passes it to that reference to person. Okay, so now let's run this code and see what happens. Okay, now our console has logged hello partner. And that's because when we called this function, we gave person the value of Martin, and this if statement cleared. It passed because person is equal to Martin. Therefore, we enter and console log this. And that's what happened here. Okay. Any questions about this so far? Parameters, invocations, functions. Let's start a poll. This will be the last poll. How well we feel we understood this last subject here. Parameters, passing in values. And so we can call this function as many times as we want now, and we can pass in whatever parameter we'd like. Greet someone. And what's the name that we can give? Let's give it the name of John. Okay. Now this function is going to run twice. This is the first time we press the start button. This is the second time we press the start button. The first time we press it with the word Martin, we pass in Martin into person. The second time we're passing in John into person. So let's see what happens to our console. Who can predict what's going to happen now?
I want to say both greetings.
Right.
Hello, Earthling.
Both greetings are going to get triggered. The if statement is going to get triggered when Martin is passed, and the else is going to get triggered when John is passed. Okay. Play with function calls and returns on trace, just the way I'm doing. Make a little change, run the code, see if it runs any differently. Delete something small, see if it runs the same. See if you can make it break and fix by tinkering with it, just the way you saw me do it today. The only thing I didn't do on trace today was the return, right? So this is the last thing. I think I'm going over time a few minutes, but it's okay. If we return something, if we returned person at the end, how would we print that person that I am passing in through this parameter? How can I get it to print the person to the console? Who can give me...
calling function?
Okay, so calling the function. So how do I call the function?
It's a console.log.
Okay. That's okay. So this is how we print to the console. All right. And you said call the function.
It's called function called greet someone.
Okay. Greet someone. All right. And then we open and close the parentheses. And do we want to pass in a name? What if we do this without passing a name? What would happen?
Wouldn't it give you both persons that you've put in?
Well, for this specific, this is its own call.
Okay.
This is its own function call within a console log. So this is the name passed in for this function call, Martin, and John is for this function call. So this one has to have its own individual name in order for a name to be recorded here in person. Because in each function call, the name is recorded, it finishes, it's done. Okay. So what, actually, let's just run it like this. Let's see what happens like this. I think I may be talking too much here. Okay, so we have the first function call. We got Martin, printed hello partner, John, and now greet someone. And yep, what happens is it greeted it went to else console log greetings earthling because it wasn't Martin, right? This function call, it wasn't Martin. So it went to this else. And when we returned person, it came back unidentified. Why is that? Why is it unidentified, the last value on this console?
We didn't include a name.
Yeah, I mean to say undefined, not unidentified. Undefined. Yes, and that's because we didn't include a name. So it went to print something that we didn't include, right? It's like that. Remember that analogy I gave of no name? All right, so now we got to give a name. We'll give it Fred. And so now Fred on this last function call is going to be passed to person. Person is then passed into this return. This return gives that name back to the function call, back to this here. And so what we should see now is that name printed at the very end. Fred at the bottom of our console. Okay, so if printed Martin, okay, now we're on John. It goes to the else. Last one. It goes to the else, prints console, and it returns person. And here we have Fred. Okay, so person is passed to here. Here it passes it to here. So the value that we give it is the value that it returns. The value that it returns is the value that it gives to the function call. So when we console log the function call, we are console logging the value we originally gave it. So we're returning what we've originally given it. Okay. All right. And now this is truly the last poll that we'll take for the day. And then we'll close out this lecture and then open up breakout rooms. Okay. Seeing better numbers this time. Oh, actually, it's getting worse. No, it's mixed. It's hard to tell exactly. Have to dig into the poll. All right, so let's stop my screen sharing. Actually, before that, let's look at the calendar. Today, our assignments, what we're going to do to practice what we've just learned, and you want to solidify this right after the lesson, is do these code challenges, predict functions, code challenge, return, code challenge, debug, and code challenge parameters. And by the end of the day, we should have this done, code challenge parameters, a practice assignment where we are going to get a greeting depending on what we enter. All right, it's a Star Wars themed exercise. It's going to be super helpful if you understand and can create this. So I highly encourage you to do this practice assignment. You really want to do this one, parameters. Okay, I've seen a lot of light bulbs click when people worked on this challenge. Okay, again, your homework is reading up and through belt tips and strategies, because that's going to be the focus of tomorrow, your first exam take. We're going to go over more for loops tomorrow morning, and then we're going to give you a little bit of prep before the exam. We're going to go over any questions you may have. I really encourage you also to get all the way through level 12 on the Algo app and go beyond. There is, past level 12, there is some code that you can write, challenges that it will have you writing code and it will check what you've written. I'll give a little bit of tips, a little bit of preview of tomorrow's exam. What you should expect is 7 of the problems are going to be you predicting the output of a function, okay? 7 of the problems are going to be you predicting the output of a function. 3 of the problems are going to be you writing code, writing functions in a code to solve the problem. Okay, so you're going to have to write at least one function tomorrow to pass. Okay, you're going to have to at least write one function on your own, and you're going to have to interpret 7 other ones. Or unless if you miss one of the first 7 and you nail all last 3 where you have to write code, as long as you get 8 out of 10, that's all you need to pass. Okay, and it's not as lots of students have finished the test and said, oh, you hyped it up way more than you should have. And you know, it's just part of this week. You have to pass this in order to go on to next week. But it's 7 reading algorithms and predicting their output, and 3 of them you have to build the code yourself. Okay, so let's go ahead and stop the recording. Does anyone have any questions before I do that? Okay, nope.